Key concepts and assumptions. This digital course doesn't require deep pre-experience in the security, photography or engineering. It is designed for those who work in a field that combines all of these disciplines. Who is this course intended for? Legal advisors, law enforcement officials, security detectives, security designers, site engineers, maintenance engineers, emergency response teams, security operators, security managers, and of course the security consultants. In this digital course, we assume that audiences have simple information about digital photography and associated terms like pixel, resolution and FPS. This digital course is based on general codes of practice and the related effective international standards. It is not aligned or biased or promoting a specific product or brand. To gain the maximum benefits of this course, it is crucial to know the following: the general functions and applications of the CCTV cameras, to expand your imagination and conceive where the values are added. The scope of this course, to set your expectations before you dive in. And the roles of CCTV in security applications, to emphasize on this specific field. The general functions and applications of the CCTV cameras. Security surveillance, which is the core of our course. Management affairs. Quality management. Production management. Education and training. Hazmat management. Military applications. Health, safety and environment, abbreviated as HSE. Maintenance. Crowds management. Climate forecasting. Sports and entertainment. And research and development, abbreviated as R&D. In fact, the applications of CCTV cameras are only bounded by imagination and the available technology. Cameras are pillars of many industries nowadays, and they compose a critical asset, as an important element of the most advanced smart electronic devices. The scope of this course. This course name is the Principles of CCTV Design for Security Applications. Hence, it will only discuss the security surveillance related roles of the CCTV cameras and will prevent other applications. The roles of CCTV in the security applications. First, we must believe that technology can never replace humans. Therefore, CCTV cameras are to aid and enhance the performance of the security staff members, not to do the security jobs on behalf, or instead of the security staff. In fact, CCTV cameras are not more than artificial eyes and sensors, equipped and well designed to support the security crew by adding extra capabilities to them, like better detection features, reduced human errors, mitigated collusion, and less feebleness. Technically, the camera converts the scene information from light nature to be electronic signals. The light is gathered by the lens and focused on the image sensor inside the camera. Therefore, the camera gathers the scene information by collecting the light reflected from the objects in the scene utilizing the proper lens, then it acts as a converter which converts the light information to electromagnetic signals, or more specifically digital signals. I remind you that technology can never replace human, then the real final destination of the captured scene image is the human, or the security operator. Unfortunately, human beings can't see or sense the signals. Here we need another converter to reverse the first conversion back from digital signals to the visible light again. This back converter is the monitor. A monitor reads the signals and shows the light representation of the monitor's screen. The camera and the monitor are reversing the function of each other. We conclude that both of them must be compatible to prevent distortion and compromisation. The CCTV operational security requirements. They are the general observation categories or presets conceived for easily guiding the processes of designing, installation, and inspection of the CCTV systems. These requirements are extracted from the international effective standards and guidelines, like the British and European BSN 62676 of 2019 and the British CCTV Operational Requirements Manual No. 28/09 of 2009. Understanding these operational requirements is the core of this course. It represents the major part of it, and truly provides new perspectives for more efficient CCTV design and operations. In ConSquare Consultancy, we consider them as 60% of the total CCTV design concepts. Furthermore, most of the authorities' regulations and rules associated with security CCTV are based on them, even if they differ in terminology or figures. The conclusion is, cameras are not positioned randomly nor specified by guessing. They are to perform specific functions as determined by the operational requirements. Note: this course is not explaining or describing any specific authority's law nor regulation, and it is not part of any licensing process in any country. The CCTV Operational Security Requirements. There are 4 key operational security requirements, almost existing in any CCTV security design. They are: identify, recognize, observe, and detect. The first one is to identify, or shortly known as ID. Why do we use ID cameras? The purpose of it is to identify an unknown individual who accesses the secured area for the first time, or who intends to perform a critical activity in the highly restricted place. This means it would be the first layer of knowing occupants, but the most important one because other layers depend on it. What does ID camera provide? Provides the proper picture quality and sufficient details to compose the confirmed identification of an individual without any doubt. How do we get an ID camera? By assigning a minimum of 250 ppm, pixel per meter, of the camera's horizontal resolution. Where are the ID cameras installed? At all entry and exit points of the premises leading from the unsecure outside to the secured inside. At all entrances of restricted zones. The second one is to recognize, or in short known as RE. Why do we use a recognition camera? The purpose of it is to distinguish an individual who was identified before by an identification camera, and to give the most details of all conducted normal activities inside the premises. What does the recognition camera provide? Provides the visual capability to recognize and keep track of an individual who was identified before, with an acceptable degree of certainty. How do we get a recognition camera? By assigning a minimum of 125 ppm or pixel per meter of the camera's horizontal resolution. Where are the recognition cameras installed? At all main lobbies and waiting yards like reception and elevator lobbies. At all queues and pedestrian flow control and drop-off or pick-up areas. The third one is to observe, or in short known as OB. Why do we use an observation camera? The purpose of it is to provide some visual characteristics to distinguish between different individuals, to the extent of deciding their general social and huddles or crowds related behavior. What does the observation camera provide? It provides some personal details of an individual, like distinguishing visual looking. Simultaneously, the field of view remains sufficiently large to show some huddle activities around the incident. How do we get an observation camera? By assigning a minimum of 62.5 ppm or pixel per meter of the camera's horizontal resolution. Where are the observation cameras installed? Wherever it is essential to monitor a group of individuals who are facing anticipated conflicts, or conducting enthusiastic activities, or in town centers. The fourth and the last one of the essential operational requirements is to detect, or in short known as DE. Why do we use a detection camera? Following an alert, the security operator has to search the display monitors to guide the response teams, and to assure the retrieval of security control stability in a balanced way. What does the detection camera provide? It provides a general view of the scene at a relatively wide and deep field of view. It provides general human activities detection like presence, direction, speed, attitude, and so. How do we get a detection camera? By assigning a minimum of 25 ppm or pixel per meter of the camera's horizontal resolution. Where are the detection cameras installed? At premises surroundings and open yards, perimeter, driving pathways, walking passages, corridors, landscaping, and car parking.
But after all that explanation and description of the 4 different essential operational requirements, how does the image look like? How does the identification, or recognition, or observation, or detection camera look like? Are these cameras manufactured to be like that? Can we use the same camera for identifying and recognize at the same time?
Well, these are good questions to answer. First, let us answer the question, how does the image look like? We remember that a monitor is the reverse converter to convert the signals back to images. So, this is our monitor. I remind you again that both devices, I mean the camera and the monitor, must be compatible. Assume we have this HD monitor, and the video is captured by an HD camera as well. The ID camera will show the targeted individual figure this way. You might see the size and details shown to achieve the goal of identifying an individual. In the same scene, if we set the camera to be a recognition camera, it will show the same target at this size and details. Obviously, if set the camera to observe, the same scene and the target will look like this in size and details. Finally, the detection setup will show the same target at this level of details. Please imagine the size of the surroundings in each category. A reminder. There are 4 key operational security requirements almost existing in any CCTV security design. Identify, recognize, observe, and detect. However, extra 4 operational security requirements might exist in some CCTV security designs. Inspect, helicopter, artificial intelligence analytics, and number plate recognition (NPR) and automatic number plate recognition (ANPR). Notes. Operational requirements are to suggest appropriate image quality, to aim towards when specifying a system to meet a particular requirement, rather than just to define a minimum standard. Obviously, cameras are not identifying the individuals by themselves, unless they are equipped with special artificial intelligence modules for smart detection. Usually, identification and all other operational requirements are done by CCTV operators. Now let us introduce the standard person stature. Stature height equals 160 centimeters. Furthermore, it should be upright, standing on feet, facing the camera, disclosing face, looking straight forward, and natural human skin color. To achieve the mission of identifying an individual, we shall simulate this case. A normal door, leading from outside to inside, and this is a standard person trying to access the premises. We will calculate the proper camera resolution to achieve ID scene here. This is how it should look on the monitor. Since the scene width is 3 meters, and identification camera requires 250 pixel per meter at least, then this scene needs 3 times 250 equals 750 pixels horizontal resolution. What is the result if the scene is wider? 16 meters for example. It will be 16 by 250 equals 4000 pixels minimum horizontal resolution. At glance, identification requires at least 250 pixel per meter as a minimum pixel density of the scene width. What is the effect of using a different pixel density? A question for further discussion. It is highly recommended to know the following topics and terms: standard stature, elements of security, 5D security model, response time, access control zones, Rothakin survey test, field of view, FOV, and lens terms.
But where is the best place to install the camera in?
Well, it is a complicated question, and I prefer to derive partial questions from it to make the answer much clearer and easier to understand. Your questions can be cannibalized the following list of questions. What is the direction of the camera? What is the height of the camera? What is the distance between the camera and its targeted focusing line? What are the spatial concerns? Then we can answer them one by one. Where is the best place to install the camera in? Theoretically, in the center of the scene, straightly facing the targeted individual, and at the height of standard stature. Practically, site's conditions mandate to deviate from the theoretical position to prevent disruption, obstacles, and tampering. Here I suggest other questions for further discussion. What are the non-standard stature and the special cases associated with it? Why it is rarely possible to achieve installing the ID camera in the ideal theoretical position? How can the 3 elements of security and the 5D security model eliminate security challenges? Now, it is time to answer the question: what is the direction of the camera? Please note this is a top view diagram and we are studying this case from above. The optimal angle of the camera direction is 0 along the movement axis and straightly facing the targeted individual. This angle assures to capture the full horizontal characteristic features of the face to achieve the identification. Up to 30 degrees to the right or left of the movement axis, the camera can still capture the sufficient horizontal characteristic features of the face to achieve the identification. A summary of the applicable horizontal angles. These angles are concluded by Consquare Consultancy based on in-house research and development experiments. It is the turn of the second question to answer. What is the distance between the camera and its targeted focusing line? Distance calculations. General principles and rules. Number 1. The distance between the camera and its targeted object directly proportional to the equipped lens's focal length. The longer the focal length, the farther the object from the camera. Number 2. The focusing line is essential to be determined correctly, especially when it is the identify operational requirement calculations. Depth of field has a significant effect on selecting this line for low light scenes. Number 3. Both the distance, capital D, and the focal length, small f, are measured by meters, but the focal length is quite short as compared to the distance. Therefore they are measured by different units of the length. Distance is measured by the meter and focal length by the millimeter, so units must be unified whenever calculations are performed. We have the main formula for calculating the distances. It is crucial to unifying the units of all parameters to be in millimeter. As illustrated in the case diagram, the focal length is corresponding to the distance, and width of the scene is corresponding to the width of the image sensor. Actually, the heights of both are also correspondents. Notwithstanding, by simple crisscross multiplication we can conclude the focal length formula or its correspondent distance. Similarly, different versions could be concluded for the rest parameters of the formula. The condition is to have 3 known parameters in the formula in order to calculate the missing fourth one. Here, the case has a predetermined location of the camera. This means the distance is known in addition to the width of the scene and the image sensor. Then we need to calculate the proper focal length in order to achieve such the specific operational requirement. This formula is applied to do so. The summary. The primary formula is here, and by simple crisscross multiplication, we can derive 2 formulae. This one to your left for calculating the focal length. We use it if the distance is determined, and we have to install the camera in a certain place, so the camera position is decided and the decision is permanent. We calculate the focal length to specify the proper lens to focus correctly on the target. On the other hand, and towards your right, we use this formula to calculate the distance. If the lens is specified and the focal length is determined, we calculate the distance to decide where exactly to position the camera. Finally, please remember the units unification, all to be in millimeter. Reaching the question. What is the proper height of the camera? Let us answer it. Please note this is a side profile view. This is the optimal height, exactly the same height of the target stature. The standard stature height is 1.6 meter. At this height, the tilt angle of the camera is 0 along the horizon. From this point, with this angle, the full details of the face are correctly captured. Practically, putting the camera at this height of 1.6 meter from the finished floor level, will expose the camera to many risks and the clear line of sight is not guaranteed. Therefore, we tend to raise the camera position above the horizontal line. The condition is to maintain the right view angle, to keep identifying the faces of the standard targeted individuals at high certainty. In ConSquare Consultancy, we found that the maximum angle above the horizon to correctly capture the face details is 30 degrees. This is the maximum angle above the horizon to correctly capture the face details. Sometimes and under certain conditions, the choice to go under the horizontal line is more feasible. In this case, the maximum angle to go down is 20 degrees under the horizontal line at the 1.6 meter. Actually, exceeding these two limits of plus 30 degrees and minus 20 degrees will result in missing essential characteristics of the face, which will result in a reduction of the identification certainty. These angles are concluded by ConSquare Consultancy based on in-house research and development experiments. First, please accept my sincere apologies for this congested slide. It looks like an ugly piece of a pirate treasure map. Here, we want to decide at which height we are allowed to install our camera for identifying functionality. As illustrated, the camera can be installed at a range of acceptable height value. Therefore, we need to know the limits of this range. In other words, we must calculate the maximum and minimum values of this range. It is quite obvious that shifts, up and down, are directly proportional to the distance. Therefore, this value a function of distance, and changes by changing the distance between the camera and the focusing line where the target is located. Here it is, within this range from the maximum to the minimum height, it is correct to install the identification camera at any convenient included height. Please note that it is preferred to go to the shift up rather than down unless the site condition and the security demands state something else. The following questions are for your further discussions. It will be delighting to get their answers. What are the site conditions or security demands urging to shift the camera down? Since the height is a function of distance, is it possible to have the camera underground? What is the ground intersection point? Are these calculations real? What about CCTV design tools? More questions for you. Is it mandatory to perform these calculations? Who is responsible to perform them? Do these calculations produce any impact on cameras or lenses specification? What is the effect of the light intensity on that? What about recognize, observe, detect and other operational requirements? Further on identify. Special cases discussion. Climbing stairs. It is quite difficult to identify individuals during stairs use because they are at most looking downwards to watch their steps. Even when they tend to explore, they look straight forward, not upward. Due to the architectural and structural nature of the stairs, cameras must be installed at high elevations to prevent tampering. The solution is by choosing another focusing line. We suggest to position it either after the final landing of it, or before the stairs. In both positions, it should be where the individual walks normally, looking straight forward. Handicap entrances. The face is not at the standard stature height, less than 160 centimeters. Depending on the case, 2 or more cameras can be used. 5D model and 3 elements are crucial concepts here. Strollers are similar cases. Wearing baseball hat. They are visual obstacles covering key characteristics of the face and stumbling identification. Security elements must cooperate to apply rigor rule to tackle it, and utilize lower zone ID camera. Special cases are countless and continuously varying. If any of you has one and wishes to discuss it with us, please submit it to knowledge@consquare.net. We are reaching the end of part 1. In this part, we have briefly discussed the essentials and the primary concepts of the CCTV design for security applications. Then, we detailed only one of the 8 categories of the operational requirements, that is the identify. Still, 7 operational requirements are not discussed yet. Next parts would pass by them thoroughly. For further explanation, please contact us on knowledge@consquare.net.